Descriptive statistics versus inferential statistics. Okay, let's find out. What is a descriptive statistic? Descriptive statistic is what is going on. Descriptive statistic pretty much means what is going on, what happened here. Okay, so what happened here? This is all about describing and summarizing the data you have right in front of you. So you have piece of data, you can short the data. So let's say you have 20 exam scores, you can short the score in a ascending order or descending order, and then after that, you can analyze the score. So you are not making any guesses about anything bigger, you are just telling the story of your specific group. So you have 20 scores, you can sort them in descending order, ascending order, and then you can tell the highest score, the lowest score, or maybe like most people, they score at this range, and then not that many people score at this range. What's the goal? The goal is take a big, messy pile of data and then make it simple and understandable. Okay, so you sort the scores, and then instead of a bunch of scores shuffled all together, you just sort them. So you organize some stuff to make that looks easier, to make that look simpler and easy to understand. So I am giving you a pile of numbers. So instead of just holding it, you sort the values in ascending or descending order. So when you look at it, it's easier to understand what is going on. What you can do is you can draw a graph. So you can draw a bar graph. And let's say after we finish statistics course, I have that many A, B, C, D, and F. And then let's say you cannot say it doesn't make sense that in a roster, the first 10 person got an A, and then the next 15 people got a B, right? So usually when you the students, the name of the students, they are sorted by in alphabetical order by your last name. So you are the first person in that class, it doesn't mean you get an A, right? So sometimes if you look at the entire grade column, the A's, B's, C's, they all shuffle up. Okay, so and then instead of use a pencil to count, okay, so there are that many A's, that many B, and that many C's, you can sort them. So A, and then you write out a list of A. So let's say you read through the roster, there are 17 A's, and then you write A equals to 17. So that means 17 students got an A, and then maybe a 15 got a B, 10 got a C, so on and so forth. And then you just organize the data to make it simpler and easier to read. And then after that, you can draw a graph. You can draw a bar graph. Okay, A is that many, B is that many, C is that many, D is that many, and then we have that many of F. So basically, you are organizing. You are doing a very first step to sort the data to make it easier to read and easier to understand. You can just sort them, and then you can draw a graph, so on and so forth. So my example is 50 students in a statistics class took a final exam. We can do number one, calculate the average score. I add up all 50 score and then divide it by 50 to find the class average. And then what about the second one? Draw a bar chart showing the number of A, B, C, D, and F. This is a descriptive statistics because they describe what happened in the exam. So instead of just giving you a pile of scores, you sort them, you graph them, so you can demonstrate to your readers about what is going on. Make a pile of number to be something that is easy to read and easy to understand. That is a descriptive statistic. Inferential statistics is basically the next step. So what is next? We are trying to make a prediction. That is inferential. Descriptive, first step. Inferential, we do something deeper. This is where you go beyond your data. You use information from a sample to make an educated guess and inference about a larger population. Population, big picture, many people in the population, you cannot handle such a big data. And then therefore, you take a random sample, okay? You take a piece of sample from the population. So instead of having one pile of data, you use descriptive statistics, you sort them, make them easier to read and understand, and then you are about to go to the second step, which is make an educated guess and inference about a larger population. So you study this sample, and then you say, okay, this is the result, and then that result applies to the whole population. The goal is to make predictions or conclusion about a large group when it is impossible to measure everyone in it. Population is big, you cannot handle it. That's why you need to take a sample and then you study the sample. The big idea is there there is always some uncertainty. We use the word like confidence, margin of error, and probability. So we will be using that, but we haven't introduced those yet. I would just say, whatever you believe it is, just use your definition. So it is okay to use your definition right now. So you believe that confidence is whatever that comes to your mind, just use that definition, okay? Because later on, I will introduce what it is, and then I will correct your thoughts. Questions to answer. Based on this data, what can we infer or predict? Okay, we have a sample, and then let's say we have what kind of population. Let's say the population is very big. I taught a class so many times. I gave this same exam so many times. I have so many scores. And then I will just take a random sample of that study. Okay, the average score is 85%. So this is from a sample. And then you are saying that, okay, so this person taught this class so many times, gave the same exam so many times, we took a sample, the average score is 85%. Okay, that means when you take the same exam, so let's say you will be taking this person's class in the future, and you will be taking the same exam, my best guess is you are going to get 85% on the test. This is just my prediction. Okay, continue from the previous example, we have 50 students took a final exam, and then we have average score, and then we have the exam, we have A, B, C, D, F, and then continue from this example. And then we got scores. Let's say this is one of my 5 statistic classes. I only studied the data from one of my 5 classes. The average score is 83%. I can predict that the average of my other 4 classes should be around 83%. This is only one of them. I am using this to predict the rest. The rest should be around 83%. What do I mean by should be around? People say this all the time. How much money do you spend weekly? You will say that number should be around $500. You don't say that number is exactly $500, right? You are giving someone else a more flexible value. So what is 83%? Around 83% is actually an interval estimate with some margin of error. Let's say 3%. How do we use the 83 and the 3%? Easy. We will be doing this. We will be using 83% plus or minus 3. 83 minus 3 is 80. 83 plus 3 is 86. So that creates an interval. This is the lower limit, and then this is the upper limit. So let's say in the other 4 classes, my prediction is the average should be around 80 to 86%. So let's say you are one of the students in those 4 classes, and then without looking at anything, my prediction is your score should be around 80 to 86% instead of saying your score is exactly 83%. So providing an interval is always a better way to make an estimation. All right, so that is the end of this video. I will see you all in the next one.